another thing is that it's more abstract and modular also. So straight away you can see a number of advantages. And I'm going to run it just to show that you get the exact same results. So it proves it's a correct implementation. Now, another very important function in the functional toolkit is reduce, which is sometimes misunderstood. So map is the more common, which probably a lot of you have already used it. But reduce is used in another context, which I'm going to demonstrate now. Sorry. So another problem, which is to calculate the total price if you have a list of prices. That would be pretty similarly to what we had before, the imperative approach of going through the values in the array, summing them in an accumulator variable, and we would get the result, which is that, and you can see that from just visually inspecting, it's the correct result. And here we have the functional equivalent, which again, instinctively just looks much more simple and elegant and readable. So reduce works by, you pass it a collection, an initial value for your accumulator, and then you pass it a function that will run on the accumulated value and the value that you're iterating currently. So in our case, we want to sum, so we create a sum function, which just adds two values. We start with the initial value, and we just add that 10 to that. Then the next iteration, we'll have that result 10, which adds 20. And the next iteration, we'll have 30 as to the one of the operands, and add 30, and you have your result. Sorry, and running it, you can see that it's again correct. The next one, which is really useful also for very common situations, is filter. So you also have it in the array class in JavaScript. And again, we have another problem, which is a list of prices, and I've called happy prices the ones that end in 99, which are the ones that people instinctively think that are cheaper just because they are 1 penny less than the other ones. And we want to get to filter out of that array of prices just the happy prices. And again, a very similar approach, we just loop through the array. We need an inner if to check if our price is one of the prices we want in, and if it is, we push it into the result array. I'm going to run it for you. And you can see that from our initial array, we indeed have as a result the array of the happy prices. And finally, the functional equivalent using filter, which again, in my opinion, is much more readable. I'm going to run it for you before I explain it. You can see it gives the exact same result. We have two functions, and I'll explain why. So we have one that just calculates if the decimal part of a number, and then we have another one to compare that with 0.9, which is the value we want it to be larger than. So one of the important things in especially in pure functional languages, is that we don't have mutability. So we don't have variables that we assign values to. And if you notice in all these examples I've shown you, I do have a variable here just to give a shorter name to that expression, but there's no variables anywhere apart from the ones that we use to store constants, basically. And that's very important for reasons that I'm going to show you next. So another very important technique in functional programming, and you can also apply in most languages,